Hi there, class. Well, in the last two lessons, we've been adding, subtracting, multiplying polynomials, learning all kinds of things about classifying them. So you had to know what was coming next. You had to know we were going to be dividing polynomials. So lesson 6.3 is all about dividing polynomials. And our three learning goals are to, number one, use long division to divide polynomials. Number two, use what's called synthetic division to divide polynomials. And finally, to use synthetic substitution to evaluate polynomials. Okay, so I hope I didn't scare you off with that term long division. Sometimes we have a little negative connotation with that from back when we were using long division to divide numbers. But polynomial long division is a method for dividing a polynomial by another lower degree polynomial. And yes, it is very similar to dividing numbers. Now, when we divide numbers using long division, or what we call arithmetic long division, we have a few special terms. The first one is called the divisor, and that is the number we're going to be dividing into what's called the dividend. And then what we get when we divide the dividend by the divisor is the quotient. And sometimes we even have a remainder left. And we, in this case, we were dividing 277 by 12. And the way we did it is this. We first looked to see how many times does 12 go into 27. And we could see that it goes in there 2 times. And so we took 2 and multiplied it by 12. And we got this 24 here, which then we subtracted. And we got 3. Then we had to bring down the next term, which was the 7, and now we look to see how many times did 12 go into 37. So then we were seeing how many times does it go into 37, and we could see that we could put 12 into 37 3 times, and then 3 times 12 is 36, so then we subtracted that 36, and we had 1 left over, but we had no more terms, no more digits to bring down, and so that meant we had a remainder. Now here's an example of polynomial long division. We also have a dividend and a divisor. So the dividend is the number that we're going to be dividing into, or the polynomial that we're going to be dividing into. The divisor is what we're dividing into it. And what we get as a result is called the quotient. So in this case, my dividend is 2x squared plus 7x plus 7, and I want to divide x plus 2 into it. So what I do is, instead of looking at the whole x plus 2, what I instead do is I look at the x and I see how many times will the x go into the 2x squared. And I know that if I divided 2x squared by x, I would have 2x that remained, because I would be able to cancel out one of the x's to bring that down to 2x. Now if I took 2x and I multiplied it by x, so if I took this number in the quotient and multiplied it by that first term of the divisor, I would get 2x squared. And if I multiplied it by the 2, I would get 4x. So 2x times this whole divisor of x plus 2 gives me this 2x squared plus 4x. Now that's actually what I'm going to subtract. Just like over here in the arithmetic long division, I subtracted 24, which was the product of 2 and 12, the divisor. And so if I multiply 2x by x plus 2, I get that 2x squared plus 4x. I'm going to subtract that from the terms above it. So if I subtract 2x squared from 2x, those cancel out. If I subtract 4x from 7x, I get 3x. So then I look to see how many times will my first part of the divisor, that x, go into 3x. And I can see it goes in here 3 times. So that goes into my divisor, or into my quotient, excuse me. And then I take that 3 and I multiply the divisor by it. And I get 3x plus 6. And I'm going to subtract that from 3x plus 7 that was left over in the prior line. And when I do that, 3x minus 3x, those cancel out. 7 minus 6, that leaves me with a 1, and that 1 is my remainder. So you can see in so many ways dividing polynomials using long division is very much like dividing numeric values using long division. So let's take a look at an example of long division of polynomials. So I want to divide negative y squared plus 2y cubed plus 25 by y minus 3. And so my first step would be to write the dividend in standard form, including terms with a coefficient of 0. And what that means is if I have any missing terms. So notice I have the highest power on my polynomial is this 2y cubed. So I'm going to write that first. So I have 2y cubed. Well, the next term will be the next power down, which is that minus y squared. Now notice there's not a y term. So if that's the case, what I need to do is put a placeholder there and use a 0 coefficient. So that's 0y. And that's, so I have y cubed, y squared, y to the first. So then a y to the 0, which is 1, really indicates that's actually the exponent on the constant term. So now I'm to the constant term, which is 25. Now that is my dividend. And my divisor is what I'm going to divide into it. So I'm going to divide y minus 3 into that. So here's how I do that. I first look at the y, and I see how many times does the y go into 2y cubed. So if I divided 2y cubed by y, I would actually get 2y squared. So what I'm going to do now is I'm going to take this 2y squared and kind of off to the side, I'm just going to calculate what that times the divisor is. So 2y squared times y minus 3, that is going to be 2y cubed minus 6y squared. And what I'm going to do is I'm going to subtract that from the terms above it. So when I subtract my 2y cubed from 2y cubed, those cancel out. That should always happen. And now I have a negative y squared minus negative 6y squared, which really means minus negative is a plus. So that's really minus y squared plus 6y squared, which is a positive 5y squared. So now then I'm going to bring down the next term. So that next term, if I bring it down, is a y times 0 or a 0y. And so now I'm going to look to see how many times does that y in the divisor go into 5y squared. So it will go in there 5y times. So now I'm going to go over here and take that 5y and I'm going to multiply it by the divisor of y minus 3. I'm going to do that again. And what I get is 5y squared minus 15y. And I'm going to subtract that. And I always put my parentheses out in front to remind myself that I'm subtracting both the 5y squared and the negative 15y. And now I'm going to go ahead and subtract. So 5y squared minus 5y squared, those cancel out. That should happen every time. And then I have 0y minus negative 15y. That actually makes a positive 15y. And now I got to bring that final term down, which is a plus 25. And I'm going to go back up again, and I'm going to see how many times does that divisor go into that first term. And that first term is 15y, so y goes in there 15 times. So I go up here in my quotient, I write plus 15, and I'm going to take that 15, and I'm going to multiply it by y minus 3, and then I'm going to subtract it from 15y plus 25. So that's going to be minus 15y, and then 15 times negative 3 is negative 45. And so when I subtract 15y minus 15y, those cancel out, and 25 minus negative 45 actually gives me a total of And so when I subtract the negative 45 from 25, that minus negative becomes a plus, and that leaves me with a remainder of 70. And so how I would actually write that in its final form is that 70, which is my remainder, would actually be 70 over y minus 3. Just like if I went up here and looked at my arithmetic long division, if I were to write out the final quotient, I would actually write this as 23 and 1/12. So we always write our remainder as a fraction of the divisor, just like we're doing here. So this would be my final answer. This would be the quotient of those two polynomials. 2y squared plus 5y plus 15 plus 70 over y minus 3. So that's what long division looks like. Let's turn the page and take a look at another example. Okay, so this time my divisor is 3x plus 1, and my dividend is 15x squared plus 8x minus 12. Now this time we didn't have any terms missing. We started at the squared and we went down to the raised to the first, and then no exponent at all. So we just had that constant term, so we didn't have to fill any zero terms. So now we take a look and we see how many times will 3x go into 15x squared. And so we know that 3x, if I divide it into 15x squared, will give me 5x. So now I'm going to go over here and take, just kind of off to the side to do my calculations. I'm going to take 5x and I'm going to multiply it by the 3x plus 1, which is the divisor. And I'm going to subtract that from the 15x squared plus 8x. So when I distribute that 5x through, I get 15x squared, and then 5x times 1 will be 5x. So I'm going to be subtracting that from 15x squared plus 8x. So of course the 15x squareds cancel out, and then 8x minus 5x leaves me with 3x. And then I have to bring down the next term, which is a minus 12. So then again I look to see how many times will 3x go into 3x here, and it will actually go in there just positive 1 times. So then I take 1 and I multiply it by the 3x plus 1, and I'm going to subtract that from 3x minus 12. And when I distribute 1 to 3x plus 1, I just get 3x plus 1. So when I subtract, the x's are going to cancel, 3x's are going to cancel, and then I have minus 12 minus 1, which makes minus 13, and that's my remainder. So I would write that as either plus a negative or minus 13, but I'm going to do it as plus a negative 13 over 3x plus 1. So to write my final answer, again, I'm going to write it down here under step 4, 5x plus 1, and then I'm going to do it as a minus, I guess, minus 13 over 3x plus 1. Or again, you could write it as plus a negative if you'd rather. So that's my final quotient between those. Now, because some of this stuff can kind of be tricky, instead of doing the next example as a you try, we're going to do this one in class together when we meet again. So we're going to label this one as an in-class example, and we're going to just simply move on to the next page, and we're going to look at another way to divide, which is called synthetic division. So let's go ahead and turn